Okay, we're going to look at equations of uniformly accelerated motion. Okay, so let's begin with acceleration. Acceleration is defined as change in velocity over time. So acceleration A is change in velocity over time. Okay, what is change in velocity? Final velocity minus initial velocity. Final velocity is presented with V, initial velocity is presented with U over T. Okay, so if we multiply through by T, we're going to have A times T is equal to V minus U over T multiplied by T. So we have this, we're going to have AT is equal to V minus U. And if we make V the subject of the equation, we add U to both sides, so we're going to have AT plus U is equal to V, which we can write as V is equal to U plus AT. So this is the first equation of motion. That's the first equation of motion. Alright, so average velocity as V with a bar. Average velocity is defined as initial velocity plus final velocity over 2. Average, okay, this average velocity 2 is defined as distance over time. Distance or displacement over time. So this is average velocity, that is average velocity, which means if we equate them together, we can have U plus V over 2 is equal to displacement is letter S over T. Okay, so let's solve this. Multiply through by the LCM, which is 2T, you have U plus V over 2 multiplied by 2T is equal to S over T times 2T. So this will take out this, and then we're going to have U plus V times T is equal to this, we take out is 2S. So divide both sides by 2, you have that S is equal to U plus V over 2 in bracket T. So this is our second equation of motion. So if we substitute equation 1 into equation 2, remember equation 1 is V is equal to U plus AT. So in this equation 2 here, anywhere we see V, we put this. So equation 2 is S is equal to, we have U plus, that's V, so we're going to substitute this, U plus AT, okay, and then we have all of these over 2 and then multiplied by T. Okay, so we have S is equal to U plus U is 2U plus AT over 2 multiplied by T. Okay, so S is equal to, let's open up the bracket, 2UT plus AT squared. Everything is divided by 2. So this equation means S is equal to 2UT all over 2 plus AT squared over 2. This can take out this, give us 1. So S is equal to UT plus 1 over 2 AT squared. So this is our third equation of motion. S is equal to UT plus half AT squared. Now if we go back, remember that just use this now, V is equal to U plus AT. If we make T the subject of the equation here, let's see, we're going to have V minus U is equal to AT, and then divide both sides by A. We'll have V minus U all over A is equal to T. So if we now put this into that same equation 2 again, remember that equation 2 is S is equal to U plus V over 2 times T. So anywhere we see T, we add V minus U over A. So we have S is equal to U plus V all over 2 multiplied by T. Now we replace by this. We have V minus U all over A. So let's open up the bracket. Remember, this means U plus V multiplying V minus U all over 2 multiplying A. So if we open up the bracket, this multiply this, you have UV, then this multiplies this, you have minus U squared. And then V multiplies this, you have plus V squared, and then V multiplies this, you have minus UV over 2A. That will be equal to S. So you can see UV minus UV, that's 0. So S is equal to, so S is equal to V squared minus U squared. Just switch to this, okay, all over 2A. If I multiply through by 2A here, 2A, and then by 2A, to remove 2A as a fraction, we'll have that, and then we'll have 2AS is equal to V squared minus U squared. Okay, if we make the V squared subject of the equation, we're going to have 2AS plus U squared is equal to V squared. So we can write this as V squared is equal to U squared plus 2AS. Okay, that is equation, let's see. Okay, that's equation 4. Equation 4. So in essence, the 4 equations of motion are, so whether you know the derivations or not, this is what you're supposed to know. These 4 equations, you're supposed to have them at your fingertips. It's not every time you want to use them, you derive them. You can learn the derivation, but you need to know, you need to memorize these equations, these 4 equations. Okay, in these equations, V is final velocity, V is final velocity, U is initial velocity, A is acceleration, S is distance or displacement. I would rather call it displacement because this is uniformly accelerated motion. And then what else do we have here? T is time. The car accelerates uniformly from rest at 5 meters per second square. Determine its speed after 10 seconds. So anytime you have a position, like I said, get your parameters out. We have acceleration given here, that is 5 meters per second squared. Okay, we have time given. Okay, that time given is 10 seconds. So what are they asking us to find? It says determine its speed. Okay, that is a velocity. That's what we're asked to find. So if a car accelerates, it means that it had an initial velocity before it accelerated, and then after 10 seconds there's going to be another velocity which is going to be final velocity. So anytime something accelerates from rest, initial velocity is going to be 0. The car was at rest, that means it wasn't moving, so it didn't have a velocity. U is 0, and then it accelerated. After acceleration, it means that the velocity is increasing. Acceleration is change in velocity. If there's acceleration, it means that velocity increased from an initial value, which in this case was 0 because it started from rest, to a final value, which is what we're asked to calculate. So look at these parameters. Which of those 4 formulas connect them? Of course, you can see that it is V is equal to U plus AT. We have all of them there except one. All right, so our V is U is 0 plus A is 5 times T is 10. So V is equal to 5 times 10 gives you 50 meters. Gives you 50 meters per second. Okay, so the answer is 50 meters per second. A body moving with a velocity of 50 meters per second is brought to rest in 30 seconds by a constant retarding force. Calculate the distance covered by the body. Okay, so we're looking for distance. Okay, let's take out the parameters from the question. Alright, so the body moving with a velocity of 50, so V is velocity, but that should be initial velocity. So U is 50 meters per second. Okay, it's brought to rest in 30 seconds. T is 30 seconds. Okay, by a constant retarding force. Calculate the distance covered. So which of the formulas again here? We don't have acceleration, take notes. Okay, they just said is a constant retarding force, that's a negative acceleration, but it wasn't stated. We know that S is equal to U plus V over 2 times T. The question asks us to calculate distance, which is S. Okay, we know V and we know U. Okay, how do we know V? Because the car was brought to rest. Again, it had an initial velocity of 50 meters per second, and then it was brought to rest. So the final velocity is going to be 0. So V is going to be 0. If a car starts from rest, initial velocity is 0. But if a car is brought to rest, then final velocity is what? Is 0. So if we substitute into these, we should have s is equal to 50 plus 0 all over 2 times 30. Okay, this will give us s is equal to 50 over 2 times 30. This is 15. Okay, 15 times 50 is going to be the same thing as 150 times 5. This is 0.25, carry 2, 5 times 1, 5 plus 2, 750. So I have 750 in meters. So the distance covered is 750 meters. So a clear analysis of what is given in the question and what the question asks you to find will tell you which of the questions you are supposed to use. So let's look at this question. A uniformly retarded object comes to rest in 30 seconds after traveling a distance of 60 meters. Calculate the initial velocity of the object. Okay, a uniformly retarded object is brought to rest after 30 seconds. So what we have in that question currently is t. So t is 30 seconds. Okay, after traveling the distance, s is 60 meters. Calculate the initial velocity. So we're looking for one of the formulas or one of the equations that connect distance to velocity. Okay, if we use s is equal to u plus v over 2 is equal times t. Okay, u plus v times t. So we know that the final velocity is 0 because it was brought to rest. So s is equal to u plus 0 over 2 times t. And then s is equal to ut over 2. Then 2s will be equal to ut. So u is equal to 2s over t. Okay, so given that t is 30, s is 60, u is equal to 2 times 60 over s is 30. 30 can divide 60 to give us 2. 2 times 2 is 4. So the initial velocity is 4 meters per second. A lorry moving with a velocity of 2.5 meters per second squared accelerates at 10 meters per second squared for 4 seconds. Calculate the distance covered. Okay, so let's look at that question now. All right, from the question we have a lorry with a velocity 2.5 meters per second accelerates. That means that is an initial velocity. So 2.5 meters per second. Okay, accelerates at 10 meters per second squared. Okay, the time taken for this acceleration is 4 seconds. The question is asking us to calculate the distance covered. Okay, so distance, we have u, we have a, we have t. and we're required to calculate S. So notice here that there is no clue to finding the final velocity. So final velocity, they didn't say the final velocity, or it was brought to rest. So we don't have any clue about final velocity, so we don't know V. So we're looking for an equation that has S and there's no V in the equation. And that equation, the best equation there is ut plus half at squared. Okay, this equation does not have a V in it because we don't have V in this question, and they are also asking us to calculate distance. Okay, so you can see in this equation we have U, we have T, and we have A. Very good. So let's go ahead and substitute. So our S is equal to 2.5 times, the bracket is times 2, T is 4 plus half A is 10, and then T is 4 with a square. Okay, so S is equal to 2.5 times 4 is going to give us 10 plus, this can divide out, this give us 5 times 4 squared is 16. So S is equal to 10 plus 5 times 16 is 80, and 10 plus 80 gives us 90 in meters. Okay, so I'm going to take some questions from Prep 50 and then I'll give you some activities to do.